Now we've discussed the 5-number summary, the minimum value, the first quartile, the second quartile, which is the median, the third quartile, and the maximum. Now we have this numerical computation called the interquartile range, which is simply the difference between the first and third quartile. So it's going to be computed by taking Q3 and subtracting Q1. So since Q3 is the 75th percentile and Q1 is the 25th percentile, the interquartile range will have 50% of the data will fall in that particular range. So the interquartile range gives us a spread of the literally middle 50% of the data. So if the interquartile range is large, the data are spread out, and if the interquartile range is small, they're close together. So the interquartile range is going to give us a measure of spread. All right, so here we have the interquartile range, Q3 minus Q1, and we've abbreviated interquartile range as IQR. And now we want to have a formula that will give us a way to distinguish between what we think are probably outliers. Outliers are data values that are far away from the center or the rest of the data. So what we're going to create here are fences, and I guess it's kind of aptly named. Think about having a ranch where you have a bunch of farm animals, and if they wander outside of the fence, then they're outliers. So you can kind of visually think of these fences as barriers, and if a data value is outside of those barriers, then it's probably an outlier. So let's go ahead and kind of write out the formula for these in more detail for these fences. So a value that is less than the first quartile minus 1.5 the IQR is considered an outlier. That's called the lower fence in many contexts in textbooks. Similarly, a value that is more than the third quartile plus 1.5 times the interquartile range, also called the upper fence, is considered an outlier. So we're going to consider a data value an outlier if it's 1.5 the distance of the interquartile range below the first quartile, or if it's 1.5 times the interquartile range above the third quartile. So if it's too far to the right, meaning it's too large, how large? The third quartile plus 1.5 the interquartile ranges, it's going to be an outlier. Or if it's too small, how small? If it's the first quartile minus 1.5 times the interquartile range, we'll consider that an outlier as well. So if you didn't do this by hand, which I don't suggest we do this by hand, there is a nice way to do this on the calculator. And again, you'll make a list, and you'll do one variable statistics to that list. You'll hit calculate. And the 5-number summary is actually displayed on your calculator screen. You will have to scroll down, but it will give you the minimum, the maximum, Q1, Q2, and Q3. Although Q2, it doesn't say Q2, it just says the median, because Q2 and the median are the same thing. To get the interquartile range by hand, you would take Q3 minus Q1. All right, so now that we have the 5-number summary, we have a way to find outliers by hand. Let's go ahead and draw a picture of these 5-number summaries. So a box plot, or a box and whisker plot, is simply a graphical display of the 5-number summary that we can get on our calculator. It doesn't matter if you draw it vertically or horizontally. Typically, we're going to draw them horizontally. The graph has different parts. The box plot or the box and whisker plot The box part of it is simply a box where the left edge is at Q1 and the far right edge is at Q3. There's going to be a middle line or a vertical line somewhere inside of that box that's going to represent Q2. And so we'll display Q1, Q2, and Q3, meaning Q1, the median, and Q3, as a box where the left edge is Q1, the middle is the median, and Q3 is the right edge of that box. We'll have this on a number line so you can actually see where these values fall on a number line. And the minimum value will be the left whisker endpoint, and the maximum will be the right whisker endpoint. And let's go ahead and look at what one typically looks like. So here I've got the minimum value at the very far left, and it's the left-hand side of the whisker. And here I've got the maximum value drawn as a whisker all the way out to the right-hand side. Again, notice that this rectangle or the box, the left edge of the rectangle or box is Q1, the right edge of the box is Q3, and the middle vertical line is the median. So depending on the values of Q1, the median, Q3, and the minimum and the maximum, the box plot can look different. But in general, I'll have this overall shape. Now, if we throw in the idea of the lower fence and the upper fence, we can have a different box plot. It's also known as the modified box plot. The modified box plot will indicate if there's outliers. If there are outliers, meaning there's data values below the lower fence, or there's data values greater than the upper fence, it will show the plot having isolated dots indicating data values that are considered to be outliers, meaning values beyond the upper and lower fence. So to do this, to draw these, we'll use our TI-84, and I'm going to just get to an example where we can see this keystrokes on the calculator directly. All right, so let's go ahead and look at an example. And something to note, when we get to a picture, if the data are symmetrical, then the box plot will look symmetrical. So if the data is symmetrical, the corresponding box plot will look symmetrical. If the plot is symmetrical, the four quartiles are about the same length, and the data are likely a near uniform distribution. If a box plot is symmetrical and both outside lines are noticeably longer than the Q1 to the median and the median to Q3, the distribution then is probably bell-shaped. And we'll see this when we see an example. All right, so we've got here example 3.7.3, 5-number summary, and I have an even number of data points. And so what we're going to do is enter these data values into a list. And the context here is I've got total assets in billions of Australian dollars. So AUD, Australian dollars, okay, of Australian banks for the year 2012. So here I've got a random sample of 2, 4, 6, 8, 10, 12 banks, and they're listing these in billions. So this is 2,855, but it's in billions of dollars, Australian dollars. So what is the individual object here? The individual object would be a randomly selected Australian bank. Okay, the variable is going to be the total assets in billions of Australian dollars, so it's in AUDs, but it's total assets. And the type of variable is definitely quantitative because it's something we can count or measure with a device, and of course we could count money. And so let's go ahead and write this up. So the individual object, like I said, a randomly selected Australian bank. The variable is the total assets in Australian dollars, and this should be, I guess it's in billions. and the type of variable is quantitative. All right, so let's go ahead and proceed with the example. Let's go ahead and find the 5-number summary. So the first step we want to do is put all of these data values in order from smallest to largest, and it looks like that's not done. So if you were to do it by hand, well, you would get this as the data set from smallest to largest. Okay. Now there are 12 data values. So here the sample size is 12. So 12 divided by 2 is 6. So it's going to be a tie for the middle between the 6th and the 7th value. So if I count 1, 2, 3, 4, 5, 6, here I'm going to have a tie between 2964 and 2965. So the first step is put all the data in order. The second step is find the median. So here, the median, because this is an even number, here the median is going to be the average of those two values, 2964 and 2965. So here is the 6th value and the 7th value. And the median is going to be the average of the 6th value and the 7th value. So I'm going to add the 6th and the 7th value together, take that quantity, divide by 2. I'm going to get 2,964.5. So I forgot to put the 0.5 in here. It's easily remedied here. Billion AUDs. So we've got the median. The next step is to find the median of the lower half of data. That will be the first quartile. And the step after that is to find the median of the upper half of data, and that will be the third quartile. But we've done the second step after we order the values. We've got the median. Because there were 12 values, there is going to be a tie between the 6th and the 7th value. And so we simply average the 6th and 7th value. And so the median is 2,964.5 billion AUDs. Okay, so now let's go ahead and find the first quartile. So the first quartile is going to be the median of the first half of data. And so notice here I've got all the data here. And the first half is going to be from 2,855 to 2,964. So that's right here. Okay. So to find the median of this, well, since there are 6 values in this lower half of data, 6 divided by 2 is 3. And so there's going to be a tie between the third and the fourth. Right? 6 is even. So there isn't going to be a middle value. There's going to be a tie between two middles. So here the first quartile is going to be the average of 2862 and 2884. Let's go ahead and write that up. So the first quartile is the third data value when it's ordered, plus the fourth data value when it's ordered, divided by 2, and so we get 2,873 billion AUDs. That's the first quartile. To get the third quartile, we take the upper half of data, and that's going to run from 2965 up to 3032. That's that data, again in order still. There are 6 values in the upper half of data. That's even. 6 divided by 2 is 3, so it's going to be the third data value in the upper half plus the fourth value and divided by 2. Let's go ahead and mark that up. Okay, so the third quartile is 2971 plus 3002 divided by 2 equals 2,986.5 billion AUDs. So we've got the median, the first quartile, and the third quartile if we were computing these quartiles by hand. Again, we had a small data set. Something to note, whenever we found the median or the first quartile or the third quartile, we did have to be careful if we had an even or odd number of values. In all of these cases, we had an even number of values, so to compute these quartiles, I had to take an average of 2 values. All right, so the 5-number summary, if we put this all together, is going to be the minimum, the maximum, and the 3 quartiles. We'll put them all in order. So here's the 5-number summary. We're going to put it in order from minimum, Q1, the median, Q3, and the maximum. Here are the numbers. Notice the 3 values in the middle are Q1, the median, and Q3 respectively. To find the interquartile range, we'll simply take Q3, 2986.5, and subtract Q1, 2873. So next, when we find the interquartile range, Q3 minus Q1, here's the interquartile range, 2,986.5 billion AUD minus 2,873 billion AUD comes up to 113.5 billion AUD. That means the middle 50% of the total assets in this sampling of 12 banks were within 115.5 billion AUD of each other. All right, so now let's look at what this would look as a graphical interpretation. So the min, Q1, median, Q3, and the max are going to be represented as a box plot. Whenever we draw a box plot, you do want to have a scale for reference here. So here the minimum value was 2,855. The maximum value, the far whisker, was at 3,032. The first quartile, 2873. The median, 2964.5, and the third quartile, 2986.5. Again, you should have a label of the context, total asset of Australian banks in 2012 in billions of Australian dollars. And you should have a scale so you can get an idea of what the picture is with a number. If we look at the distribution of this, if you look here, this right whisker or tail is a little bit longer than the left tail, and the median here doesn't appear to be in the center of the graph, and so this looks like it's skewed right simply because of this tail is a little bit longer. Now, to do this on the calculator, we'll bring up the data set. Let me bring that up all the way to the beginning. And let's go ahead and bring out our TI-84s. All right, so I've got the TI-84, hit Stat, Edit, and here you're going to enter into list 1, or whatever list you want to put these in, those 12 values. So I've done that. Again, to clear a list, if you have something that you want to clear out first, you highlight the list so it's listed in black, then you hit Clear, Enter. So I've got all those bank data values in there. Hit Stat, Calculate, one variable statistics, and I do want list 1. It's already there, but if it was not, I'd put second 1 for list 1. And we'll proceed to hit Enter to calculate. And so the 5-number summary, if I scroll, there's the minimum, 2,855. There's the first quartile, 2,873. There's the median, 2,964.5. There's the third quartile, 2,986.5. And there's the maximum. So your calculator literally will list the 5-number summary. You do have to scroll down a little bit, but it will give it to you in order. So that's how you would find these on the calculator. Now, if I want to graph this, so I've got the 5-number summary, but I want a picture of this. And here I'll just enlarge this. I'm going to hit second stat plot. And I'm going to turn only plot 1 on, have everything else off. So select plot 1. We'll make sure it's on. If it's not, then you would toggle to the on position, hit enter. And the box plot is going to be this one here on the right here on my screen. It looks just like the box plot that we were discussing in the pictures. Hit enter. And now I don't want list 3, I want list 1 because that's the list I put those bank values in. So second 1. And now I should be in a position now to graph this. Before I hit the graph button, I want to make sure my calculator puts a proper scale to this. So I'm going to hit the zoom button upper center. And then if you hit option 9, it tells the calculator to make the correct window for this stat window for a graph that you're going to make. So I'm going to hit 9 here. And there it graphs it for me. Now, if I want to see what the values are on the box plot, I can simply hit trace. And here it says the median is 2,964.5. And simply using a right arrow or left arrow, you can move back and forth. There's Q3. There's the maximum, 3,032. Moving left, there's Q1, 2,873. And there's the minimum, 2,855. And so using that Zoom 9 feature, you don't have to worry about making a window for this to graph. It just does it automatically. So again, second stat plot, select plot 1, select the icon that looks like the box plot. Don't select the one with the dots. That's called the modified box plot, which we'll get to. But for right now, that's the box plot. Put in the correct list. Don't have any list for frequencies, just have one there. And then when you want to graph this, Zoom 9. All right, so that takes us through the first example of finding the 5-number summary on the TI-84 and getting the box plot.